It's Diana, and I will tell you about the most recent and challenging project that I've done. This project aims to integrate mutated BNCA genes into the Mycobacterium tuberculosis genome, knockout for the BNCA wild-type gene to determine the susceptibility to the drug pyrazinamide. For that reason, I will use homology recombination. For the experimental part, I will start cloning the mutated PNCA genes into the integrative plasmid. Before that, I have to evaluate if the knockout strains for the PNCA genes doesn't have activity. In other words, if it doesn't produce POA. For that reason, I will use the Wayne's method. After that, I have to evaluate if the integrative plasmid works well. For that reason, I will restore the activity of the protein pyrazinamidase. For that, I will use the BNCA wild-type gene to integrate it into the genome of Mycobacterium tuberculosis to contrast it with the strain knockout for that gene. After all of that, I have to evaluate the phenotypic parameters of the bacteria. For that reason, I will measure the amount of POA produced. Also, I have to evaluate the minimum inhibitory concentration of the drug. And finally, measure the expression levels of the protein pyrazinamidase by real-time qPCR. One of the recent problems in the experimental part was the design of the primer. It has to contain a part of the sequence of the promoter of BNCA gene, but the person who has to done that make a mistake because she didn't consider the complete sequence of the promoter gene. For that reason, the expression levels of the mutated protein cannot be performed. While I was finding out in which part of the experiment the error was, I noticed that I only focused on the methods, on the media, and on the protocols, but not that the design of the primer was wrong. In other events, I think that the protocol of the homology recombination didn't work well. And for that reason, I repeat the experiments. But when I was reading an article, I read that I have to treatment before transform the integrative plasmid in the bacteria. I have to treatment that plasmid with like UV to do more easily the homology recombination. And with those cases, I learned that I have to trust and I have to believe more in the experiments that I've done. On the other hand, I've learned that it's important to have a good model and to control all the experiments that you have done. Homology recombination is a technique that have not been made in my laboratory, so I have to standardize the homology recombination. And I thought that I have to use a technique that can give me results more easily. And for that reason, I thought that a good idea could be use a GFP protein because I can obtain results more fastly because I can visualize and verify if the homology recombination works well. One of the great opportunities that this laboratory gave me is to trust and believe more in myself.